of when somebody mentions technology? What's the first thing that comes to mind? Are you thinking computers, video games? Well, believe it or not, technology is the pencil that you use at school to work out your math problems. Technology is the baseball hat that you wear at the games to keep the sun out of your face. Technology is anything that makes life a little bit easier or helps us solve a problem. And believe it or not, there are inventors that come up with these creations that help solve these problems, and they actually profit from it. It happens every single day. Maybe you've heard of the clapper. That was a neat invention to make it so we didn't have to crawl out of bed to turn off our light or turn off our TVs. Believe it or not, you can still actually purchase the clapper right now. And we're going to use our powers of innovation, and we are going to code our code node today to mimic a clap-on, but we're going to do more of a snap-on. So for this investigation, this program that you're going to create, we're going to use the sound sensor to collect the sound data, and then you're going to be using the RGB LED light as your output for this program. So just like any other time, I want to take you into SparkView and let you see the data that we're going to collect that we're going to use in our program. So my code node is on. And for this investigation into sound, I want to get various sound levels. What's interesting about the code node is it measures sound and loudness, or the amplitude of the sound, and it measures it in a percentage from 0 to 100. So what does that look like? I'm going to choose loudness as my sensor, disable the others, and bring up a line graph. It's going to show loudness over time. So what I want to do is get a good level of sound that I'm going to take that percentage and plug it into my program. So let's see how that works. I'm going to click Start. So you can see my snaps register almost up to the 100% mark. All right, I'm going to stop collecting data. So when I'm looking here, I check all these different peaks, because the number that I want to use, the percentage of loudness in my program, has to be something that's going to enable my RGB LED light to come on. So looking at that, I think I'm going to pick probably about 50%. That way I know I'm hitting the mark. So what does this program look like? Let's open up an already completed program. All right, I'm going to click the code icon so you can see it completed. We got quite a bit going on here, so I want to walk you through the program that we've created and what it's going to do. We're going to create variables today, and you probably use variables to complete mathematical applications, equations. You've certainly used variables when you're investigating, doing science experiments in science. In computer programming, the variable is something we create to store data, and we give it a name so we can recall it later in the program to tell it to do something. So we will be creating a variable here called light on. We'll do that together shortly. The program started to light on false. We do this because we want the RGB LED light to be off when the program initially starts. I have a repeat while true loop. Again, it's going to run this program over and over again until I hit stop in SparkView in Blockly. Then it's saying that if the loudness is greater than 50%, there's a couple things going on here. First, it's going to tell the light whenever there's a snap to turn the light on. But we've also put the light on false, which means when I do it again, the light's going to turn off. So again, our program, it looks a little bit complicated. It's actually pretty simple once you dive in. We're telling it to start with the RGB LED light off. When I snap my fingers, it will come on. When I snap my fingers again, it'll go off. So let's see how this program works. I want to point out that I also put a sleep timer in here because I want it to register these things slowly, because Just because you snap your fingers doesn't mean that was the only sound that occurs. There's other data points that might catch. So that delay is important in this program to make sure the light turns on and off properly. All right, let's see how this works. I'm going to click Start. So it's perfect. When I snap my fingers, the light turns on and off, on, off. All right, successful program. Let's build it together so you guys can do it at home. All right, so I am going to start a new experiment. I have my book over here to help me out. I'm actually going to be working on investigating sound. This is the last activity in the book right now. If you want to learn more about variables and how they're used in computer programming, you can also find that in the book. All right, so let's build our program. code.Node is on. I'm going to click on sensor data, and just like before, I'm going to click loudness because that's the sensor I'm using, and I'm going to disable the other sensors, choose the line graph, and then you choose the code piece to create your program. All right, the variable, the one that we're going to create is going to say light on. And again, this is going to help the program indicate when to turn the light on and off through true and false statements. I'm going to start my program with light to false. Again, telling it to start with the RGB LED light off. I'm going to pull in my loop, repeat while true. Okay. I am going to pull in a logic block that initially starts out that if the loudness, that amplitude of sound is greater than, I think we chose 50. I think that's a safe number. So if it's greater than 50%, and then you're going to bring in a nested conditional. So I'm placing another one of these conditional statements within the first to build on it. So if, and I'm going to be recalling this variable quite a bit, if the light on is equal to false, and I just pull that true block and then use a drop-down menu to get to the false. Then I want to set my light to true. Again, this is making it go back and forth from on and off with each sound that's being made. So when the light is on, I'm going to choose my RGB LED and make sure all of those are on 5. That's going to give me the white light. Remember, when you overlap red, green, and blue with RGB model, you're going to get white light. You can check out one of our other activities to learn more about the RGB LED. All right, so I need to now have an if-else statement. And I'm going to duplicate these blocks just to make life a little bit simpler. Set light to false, which means it's off, which means all of these need to be set to 0. So the light is off. And then click the gear again. And I'm going to pull this sleep timer in to make sure there's a nice pause. Bring it up to about 200 milliseconds. I want to show you what happens if you don't use the sleep timer first. So let's disable that. And you can do this anytime you're working with a program. If you're looking for bugs, you can disable certain blocks to see if they're needed, to see if you need to increase time, see what you might need to adjust in your program to get it working a little bit better. All right, I'm going to click Start. So what you're seeing right now is because a sound isn't just one data point. It's not registering the way I want it to. I want there to be a delay, so it's only picking up on that sharp initial sound. So I'm going to stop collecting data, enable that block. All right, so I'm going to press start and see how my program works. All right, start. All right, we have success. And again, if you want to check your data points, you click on the code piece again. That way, if you see a glitch in your program, maybe it's because my snap didn't hit that 50% threshold. Neat way to check your program out. All right, guys, so good luck working with variables. They're really important in computer programming. This should give you a good entry point to that and why we need them. And go out there and be innovators. See what you can invent using the code.Node and the Blockly software.